I'm Sang-Kee, the reading engine design and engineering section HHI EMDs. So it's my honor to with you spend your time despite your busy schedules. So I try to talk about the green multi-fuel engines. Okay, my presentation start with is the reason why we need is green multi-fuel engines, and followed by the green multi-fuel engines is already ready, and what kind of technology is required. The finally, I will summarize. As you know well, last week, the IMO Marine Environment Protection Committees has been adjourned for 1 year before considerations the IMO Natural Framework. However, they would have provided global regulatory framework for the reduction of greenhouse gas energy intensities, and which will eventually create the consistency and confidence and collaborations needed to drive investment and accelerate progress. Both IMO and Fuel EU Maritime provide regulatory values for greenhouse gas fuel intensity by year. Analyzing the proposed GFI shows LNG and biodiesel looks promising in the short terms, but RFMBO and e-fuels is advantageous in the long run. Any fuel faces their own unique characteristics and also challenges. The present LNGs has limitation in reducing greenhouse gas emission, but biodiesel needs to compete with other industries such as aviation industries for demand. RFMBO and e-fuels faces various technical challenges such as higher cost, toxicities, and low energy intensities. If you look at the potential fuels as future fuels, and there are biodiesel, e-diesel, LNGs, methanol, ammonia, and hydrogen, and etc. Biodiesel or e-diesel has the advantage of being able to use immediately without any modifications. But it has the disadvantages of being able to use it, disadvantage of having possibility of conflict with aviation business sectors. And methanol is a liquid phase on the ambient pressure and temperatures. So therefore, the handling is very easy and also less loss during the storage. But toxicities. Ammonia is a good advantage with no carbons, but extremely toxic. Hydrogen is also no carbon fuels, just only pure hydrogen, but extremely hard for ignition control. No matter what fuel is, using the same platform is the most effective, efficient way to respond to the market uncertainties. We are using structure and driving part the same with these diesel engines, and just on the upper part, especially for fuel, alternative fuel supplement, and also cylinder head and piston, and these combustions, composite part will be just only changed according to the used fuels. And so therefore, this kind of philosophy is good for very faster development speed, and the most of many of components can be used at the same time with diesel and alternative fuels. And this kind of things, it is a good, the better benefit for as a retrofit from diesel to any other alternative fuels. Now is I show is LNG DF engines, methanol DF engines, ammonia DF engine, LNG and hydrogen, and full hydrogen engines. I'd like to recognize which one has its own characteristics. LNG DF is already proven on the field, so extensive production experience, and also the very nice settled marine and inland, the generation plant. In methanol and ammonia is based on the diesel engines, the platform, and they just have its own components for fuel injection system and supply system, and to making a proper combustion chamber shape. And also, we are choosing is common neural system for supplying and fuels injection system, and to get the most reliability combustion performance. And LNG and hydrogen is mixing fuels combustions technology is already proven. So we reach it to almost 30% of energy fraction ratios of hydrogen. And now we are developing full hydrogen engines. It is so what is green multi-fuel engine different with the conventional diesel engines? And I'd like to point out at first is a common neural system for alternative fuels. We can get high efficiency and also ensuring safety. Second thing is boosting unit. It is patent design. It's a merit advantage of this design is the ship design part only lower pressure supply system to engine side, and then lower pressure alternative fuels can be increased, pressurized into the purpose for injection pressure into combustion chambers. And third thing is EFIPs. Its design is based on the conventional fuel injection parent types, but it is controlled is electrical control system, and we can adjust the injection time and injection volumes for each road. And fourth is hybrid injectors. This injector is designed to use the primary fuels and the second fuels at the same time. And next is a very important thing is integrated engine control system for each is alternative fuels. Yeah, I'd like to compare this between these auto cycle and diesel cycle. I think as you already have enough knowledge, even though that I'd like to point out. Auto cycle has a lot of pros regarding these very simple configurations. But we are facing is docking sensitivities, so therefore we can control the engine output limitations. In case of diesel cycle, we can keep is almost same rate with the diesel, but little complicated system, and also we need more accurate engine control system. Now, therefore, we choose auto cycle for LNG and hydrogen, and the diesel cycle is selected for methanol and ammonia. In case of ammonia, we can easily control this nitride oxide. It is very high potential greenhouse gas index. Yes, so this alternative fuel need absolutely accurate engine control system with very sensitivity and sensing and also control. This control system is, as it called, is high core. It consists of 5 modules. One thing is the main control panels for main engines, mains, and the safety control. And local operating panels is the user interface for between the machine and operators. Now, auxiliary control panels, it is some auxiliary system is needed for proper operations with alternative fuels. And the injection control modules, it means normal diesel is kept its time, injection timing, and also injection volume for each load. But alternative fuel case is we can you can adjust its time and durations. At the same time, we can control the pilot oil injection and also volumes. And next is cylinders monitoring modules. It is good interface with is fuel house and engine local control panels. This 5 module can control the charger temperatures to get the proper lambda ratios. And also at the same time, so we can control the exhaust gas bypass volume or also the gas volume into turbochargers. And the variable valve timings is assist the operator to adjust is intake and exhaust valve open and close. At the same time, we are concentrated to design is a safety system for these alternative fuels. As you know, I've mentioned before, these alternative fuels have a very toxic characteristics. So we can divide it to both systems. One thing is the structure sealing concept. We can adapt the sealing material for each alternative fuels. And also all piping system, any possibility to expose to human beings, and then we can adapt this double wall piping system. And the other thing is the sealing oil system to protect is any leakage from any component of alternative fuels. And in case of ammonia, it is easily become from liquid phase to gaseous phase. In order to protect the gaseous phase changes, and then we adapted some backup pressures just before surprising piping line. And also we can control as a crankcase pressure and temperatures to minimize any leakage through the crankcase chambers. Yes, how to control the exhaust gas emissions? The various fuels can be used on engine, and each fuel has its own characteristic. But the SCR can control these any NOx values from any fuels, and then MOCS can control these methane slips emissions, and AOCS control these ammonia's emissions. But until now, so based on the test and experience with ammonia operating, then AOCS is not required because some ammonia slips volumes can be activated with these NOx volume through the SCR. And the summaries, I'd like to point it out on these tables. All technologies for eco-friendly engines are already in place. Now is remain thing, well-defined regulations and robust fuels supply infrastructures. and decisive leadership of shipping companies, ship owners, and shipyard. Thank you.